How do we go about solving this question? Next, this question is based on trigonometric equations, but actually it is not a direct question. We have to apply some manipulations first and then we can arrive at a solution in this question, right? This is not a direct question as the previous questions that we have seen. So how do we go about solving this one? Cos 4x equals cos 2x. Now, one of the simple approaches of handling this is, take a look. We know that cos x equals cos theta can be solved by writing x equals 2n pi, this is 2n pi plus minus theta, where n belongs to integer, right? This is something that we know, right? So can we use this idea for solving this question? Yes, we can use this idea. This is cos of one angle equals cos of another angle. So from here I can say that 4x is equal to 2n pi plus minus 2x, right? Let me write x in this way. 4x equals 2n pi plus minus 2x. Right. What after this? We haven't found x for now. We'll have to find x by further calculation and simplification. So for finding x, we'll have to bring this 2x over here. But how do we bring that? This is either a plus 2x or it is a minus 2x. We'll have to consider them separately. So let's go in one direction and another direction. This is using the plus sign and this is using the minus sign. Let's write it as, this implies 4x is equal to 2n pi plus 2x, or 4x is equal to 2n pi minus 2x. This is what you have, right? Once you have this thing clear, then you can simplify this by bringing this 2x over here. This will become 2x is equal to 2n pi, or x will be equal to n pi. Obviously, n belongs to integer in this case, right? Or we can solve this one. What will this be equal to? This will give us, this will come over here. This is 6x is equal to 2n pi, which gives me x equals n pi by 3, where n belongs to integer. This is what it gives me. X equals n pi, where n belongs to integer, or x equals n pi by 3, where n belongs to integer. And yes, this or this is my answer. This or this is my answer. There's one more catch over here. N pi by 3 and n pi, if you take a look at these, what are the values of x that you'll get over here? You'll get pi by 3, 2 pi by 3, pi, 4 pi by 3, 5 pi by 3, 6 pi by 3, which is actually 2 pi, 7 pi by 3, 8 pi by 3, and 9 pi by 3, which is actually 3 pi. What are you getting over here? Pi, 2 pi, 3 pi. Ooh. Considering you have some idea about sets, do you observe that this is a superset of this? This here is a superset of this. All the elements present in this are also present in this. This contains extra elements as well, but this is a much bigger set than this. And in case of OR, we see that we have to take the common of these, right? Sorry, not the common, the union of both of these things, right? On taking the union, if you observe carefully, you will note on taking the union, if you observe carefully, leaving the answer at this stage will not be an issue. You can leave the answer at this stage also and go ahead. It's okay. But then on analyzing further, we realize that, okay, this is a superset. And taking the union will actually give me only this set. So the final answer can also be written as x equals n pi by 3. X equals n pi by 3, where n belongs to integer, because this will be included in that. This will be included in that without any worries. But is this all in this question? No, there could have been another approach. Some people would like to follow another kind of approach, and I will also like to discuss that approach, because this approach that I have discussed over here may not be useful in all the questions. Sometimes you will have to use some kind of manipulation of transforming these equations into some simpler versions which can be solved directly. Let's use that and let's see where does that take us. What is that other method of manipulation? Let's take a look at that. I can write cos 4x equals cos 2x in a different way. I can solve this in a different way. It is given that cos 4x is equal to cos 2x. Okay. Why not bring this cos 2x over here? Yes, I can do it. Cos 4x minus cos 2x equals 0. Is that okay? Yes. Once I've written this in this manner, this comes in the form cos c minus cos d. I can apply result of transformation of this difference in terms of product using this idea. Cos c minus cos d is equal to minus 2 sine c plus d by 2 sine c minus d by 2. This is an identity that we know of. If you are aware of this, this gives me further minus 2 sine c plus d by 2, which is 4x plus 2x, 6x by 2. Let's write it as 3x only. Sine of c minus d by 2, 4x minus 2x, which is 2x by 2 is actually x. Okay. This minus 2 will go over there and will become a 0, right, in the denominator. Sine 3x sine x, the product, if it is equal to 0, the product of two real numbers, if it is 0, then either sine 3x will be 0 or sine x will be 0, right? Let's use that. So either sine 3x equals 0 or sine x equals 0. Either sine 3x equals 0 or sine x equals 0. What about this? Recall. Sine x equals 0 implies x equals n pi. N belongs to integer. This is one result that we are aware of, right? Let's use that result. This gives me 3x equals n pi, or this gives me x equals n pi by 3. N belongs to integer. Here n belongs to integer. This is what I get. Or sin x equals 0 gives me x equals n pi, where n belongs to integer. What is so special about this? We have manipulated and we have solved, but the answer that we have obtained would have been same and are exactly same. Can you observe that? This or this, the answer are exactly same, and that's the complete analysis of this question. Is there anything else which remains? No, nothing else remains in this question